Describe and control a Wireshark dissector. It's amazing how each and every level of a protocol stack can be converted and translated into English so that we can look at the details. Who's doing all that heavy lifting behind the scenes? My friends, it's the dissectors. Let's begin. If you, like me, really enjoy a good movie, I think you'll also be interested in this story. Back in the 90s, I worked at Paramount Pictures. It's back in the time where they made Clear and Present Danger around the time of Forrest Gump. That's when I worked there. Not to put too far of a date on myself, but it was a fantastic place to work. I had a great time. But one of the things I learned there is that in the movie business, they have a lot of different people for different roles. For example, if an actor like Harrison Ford has a scene where there's a really dangerous stunt, they just won't let him do it if it's too dangerous. So they say stop, and they bring in the stunt double who does the actual stunt for them. They have very specific roles for very specific tasks. So you might ask, well, as interesting as that is, how does that relate to Wireshark? Well, I'm glad you asked. Inside of Wireshark, when we get a protocol and a packet in with all the various layers in the protocol stack, the dissectors are the individual components that help us decode the information at each of those levels. For example, if it's a TCP/IP protocol suite, we may have layer 2 information, layer 3 information, layer 4 information, application layer information, and there's a separate dissector for each of those. For example, we might have an Ethernet dissector which says, okay, here's the layer 2 frame, here's the source address, here's the destination address, and here's the next protocol that we're going to hand it to. So that's the Ethernet dissector doing its job for us. And that, my friend, gives us the opportunity to see what's really happening at layer 2 to do the protocol analysis that we want to. IP version 4, for example, is a fantastic dissector that we'd be using for the layer 3 information. The source IP address, the destination address, any types of precedence or DSCP bits that may be set, the time to live, and all the other stuff that shows up in the details pane, that's all courtesy of the IPv4 dissector. At layer 4, for example, if it's a TCP-based packet, we have the information for TCP presented to us in Wireshark due to the dissector for TCP. And if it just so happens that we're carrying HTTP traffic, the HTTP dissector is what's providing us the details on what's going on at the application layer. I kind of like to visual like a military operation. You have this data, and then you have the commander saying, blue team, layer 2, go, go, go. Red team, go, go, go. And the little dissectors go out, they look at their individual part, and they show up in that details pane for us to view in Wireshark. So how exactly does Wireshark understand which dissector to use? For example, at layer 3, it could be IP version 4 or IP version 6. At layer 4, the transport layer, it could be TCP or UDP or GRE or ESP or a lot of other protocols as well. How does it know? To understand that, let me share a little game that I remember seeing when I was younger. And it was at a birthday party, and somebody was giving a gift, and they handed the person whose birthday it was a note, and it says, to get your gift, go to point A. And that point A, for example, is like behind the garage or behind the car or whatever it was. So they would go to point A, and was the gift there? No, it was another note. And it says, go to point B. Maybe that was, upstairs or somewhere else. And they would go to point B. Eventually, after they went on this treasure hunt, they would then go ahead and eventually find the gift. Well, how exactly does this apply to Wireshark? Inside of a protocol stack, each layer indicates the next layer above it. For example, let's say this is the protocol stack we're dealing with, and let's say we have an Ethernet header. And what's inside of an Ethernet header? Okay, we're going to have the source and destination MAC addresses, but it also is going to point to the next protocol up. In the case of IP version 4, it's going to say, oh, what I'm carrying is type 800 in hexadecimal. And that 800 in hexadecimal means that the next protocol is IP version 4. So when Wireshark is looking at this packet and says, okay, in the Ethernet header, it says that the next protocol is 800 IP version 4, it knows exactly which dissector to assign for layer 3. It's going to be the IP version 4. Now, in the IP version 4 header, it's got the source address, the destination address, IP addresses. It's got TTL. There's probably some bits involved for IP precedence and DSCP and some other bits as well inside the IP header, but it also is going to point to the next protocol. For example, it could be TCP at layer 4, it could be UDP, it could be GRE, it could be ESP, it could be a whole number of different layer 4 protocols, and which one it is inside the IP version 4 header. So for example, if it says the protocol is 6, 6 represents TCP, and that's how the dissector for TCP would be called on to go ahead and handle layer 4. And at layer 4, the actual ports involved, for example, the well-known port for HTTP is 80. If port 80 is in use, the dissector it would call for the application layer would be HTTP. And that, my friends, is how the correct dissector can be selected based on simply looking at the various fields. And that's how the correct dissector is chosen, simply by looking at the clues, if you will, that have been left in each of the layers of the protocol stack that we're looking at. Wireshark knows a boatload of these standard ports. For example, it knows that TCP port 80 is the well-known port for HTTP, and 443 is the well-known port for HTTPS/SSL. It knows that, and it can appropriately apply the correct dissector based on that information. However, what happens if we have applications that are running on non-standard ports? What if we're running HTTP on some really non-standard port, or we're running some other application like Telnet or SSH on a non-standard port? How do we deal with that? How does it know which dissector to go ahead and assign? It's a good question. In Wireshark, what we can do is we can hope that the heuristic dissector will get it right. What will happen is it has a limited ability to look at flows where it sees traffic. It doesn't recognize the actual port number, but it could potentially guess at the protocol being used by using these heuristic dissectors. Between you and I wouldn't count on Wireshark always getting it right just by looking at the actual traffic flows and making a correct guess on what that traffic is if it's not using a standard port. So what we could do, if we start looking at traffic saying, what the heck is this? And we track it down to the workstation or server it's coming from, and we find out, oh, this is that traffic, but simply using a non-standard port. What we could do is we could go into the details for that protocol. For example, if HTTP was on port 6783, maybe some of the developers in your company wrote a special application. It's using HTTP just on a weird port. What we could do is simply go in and manipulate that dissector and say, you know what, for HTTP, for that protocol, we also want to include 6783. So we're just giving a manual configuration to Wireshark to tell it that 6783 is going to be a quote-unquote recognized port for HTTP. Another option we have is to simply right-click on the data that we want to decode and say, you know what, Wireshark, I want you to decode this as, and then select the protocol from a drop-down list. That's yet another way. To demonstrate this, let's go ahead and set up a web server that's running on a non-standard port. And to do that, let's go ahead and use an iOS router. It's sitting right here. First of all, we can enable web services on this, so it'll accept web connections. So you can manage a Cisco router via HTTP or HTTPS. And we also do not have to use a standard port. So let's use a port number, TCP port of 6783. And let's set up R2 to support that. So then we can actually send an HTTP session over a non-standard port. We can collect that data right here and then analyze and manipulate which dissector it should use for that traffic. Now the full config for R2, R1, and this switch module, they're all sitting in the Nugget Lab area in the folder for the Wireshark and GNS3 video that we did. All we're doing here is we're simply adding additional commands to R2. So having said that, let's go ahead and add, first of all, let's go into configuration mode. And in configuration mode, I want to enable HTTP on this iOS router. We'll do that with the IP HTTP server command. Then we are going to specify how we're going to authenticate. So once we connect via HTTP, we want to go ahead and tell it to use the local database, which is the running config on this router. Next, if we're telling it to use the local database, the running config, we probably ought to have a username to log in as. So we're going to create a username called admin with privilege level 15, and we're going to set up a password of Cisco. Shh, top secret. Then we'll tell it to use a non-standard port with the command IP HTTP port 6783. And I just want to verify real quick that it's actually listening on that port to make sure our syntax was all correct. We can do that with a show control plane host open ports. And sure enough, it seems to be listening on 6783. It's also listening on port 23. It's got Telnet open as well. So with R2 configured now, we can actually launch a connection over from our Windows machine right here. We can open up an HTTP session over here to R2 to 10.0.0.2. That's the IP address right here. And we can do it to the port of 6783. But before we launch that, we're going to start a capture right here between R1 and R2 so we can work with Wireshark and take a look at what dissector it chose and how we can force the dissector for that HTTP traffic on a way non-standard port. So here is GNS3. It is currently up and running. Let's go ahead and start our capture between R1 and R2 by right-clicking this link between the two of them and selecting I want to start capture. So we can choose either interface, R1's gig 20 or R2's gig 10. It really doesn't matter. We'll click OK, and that capture is running. Let's go to our Windows machine. Now I have a rotating desktop that changes periodically, but this is the same Windows 8 machine. We can verify that real quick by going to the command prompt, doing an IP config, verifying what its IP address is, and it is 172.16.10.2, so that's fantastic. Let's open up a browser. So I'll go ahead and open up Internet Explorer. Oh, so we're going to have a little extra traffic because the default homepage was Google, and so that traffic has also gone across the link from between R1 and R2. That's okay. And let's go ahead and go to http://10.0.0.2, and we'll go to the non-standard port by doing a :6783, and that's the IP address and the special port on R2. We'll press enter, and it says, okay, I need a username. We'll say my username is admin, and our top secret password was Cisco. Fantastic, and click OK, and we are in. So we're at the GUI interface, or the web interface, if you will, of R2. Now with that done, let's bring up GNS3 again, and let's right-click over here and say, I want to go ahead and stop all captures. And we're going to have quite a few packets in that capture file. Let's go open it up. So here's the actual location. In our GNS3 settings, we said under GNS3 root, Wireshark captures. That's what I did on this machine. And there's our file right there, R1 to R2 cap. In fact, I'm going to rename that. And the reason I'm going to rename it is because in the future, if I do new captures between R1 and R2, it will name it the same file and it will overwrite it. So I want to keep this. I'm going to call this non-standard port for HTTP. And I will also put this file, this capture file, in the Nugget Lab download area for this video. So let's go ahead now and open it up. So let's take a look at our capture. Wow, we have some OSPF packets. That's fantastic. That's the routing protocol that happens to be running between R1 and R2. We have a request for google.com, and then we have the response, and then we have a whole bunch of stuff that happened for Google. So if we scroll down, what we're really looking for is we're looking for a port of 6783. And we won't have to go too far to find it. In fact, there's the first one right there. And you'll notice the color coding for HTTP is normally green. But unfortunately, because it didn't recognize that port of 6783, it didn't know that it was HTTP. That's the actual protocol that was really running, and it didn't recognize that non-standard port, so it just doesn't know for sure. So if we scroll all the way through this, it's not going to see any of that conversation as HTTP. Now, we do have some other traffic below that that's always interesting. So we have a DNS request looking for urs.microsoft.com, and then we're having a conversation with this guy right here. And one of the things that's off by default is DNS name resolution. But let's say we have a packet like that, and we say, you know what, I want to know who that is. We can, right here, just click on that IP address, right-click, and say resolve name, and it will go ahead and do a DNS request for us and figure that out so we can see it. The DNS is off by default for everything because if you have hundreds of thousands of packets, it may be overwhelming for DNS to go ahead and resolve all of those by default. But I digress. Let's go back to our non-standard port here of 6783, which begins about right here. So there's our three-way handshake. We have a SYN request, a SYN-ACK, and an ACK, and we're off to the races. So our three methods of dealing with non-standard ports was, number one, hope that the heuristics inside of Wireshark automatically picks the right one and figures out what it is, which in this case, it didn't happen. Secondly, we can modify the ports associated with a protocol. For example, if we wanted to go in under preferences and say, you know what, for HTTP, one of the standard ports we would expect to see with that, to Wireshark anyway, is 6783. Now to do that, we simply go up here to preferences, click on it, and under preferences, we're going to open up protocols. We're going to scroll down to HTTP, which is right here. And we can simply add here that we want 6783 to be one of those ports that Wireshark can now associate with HTTP. So if we added it here and click on apply, it would then recognize 6783 as being HTTP. So let's go ahead and do it. So I'll put 6783, little comma there, click on apply, and if you'll notice, these packets in the background change to green. And if we highlight one of those, for example, and collapse the IP and we'll go to TCP, you'll notice that the port is 6783. Well, how did it know it was HTTP? The answer is, we told it. If it's 6783, it's HTTP, and now it knows the appropriate dissector to allocate to that. So if we keep our eye, for example, on this one, packet 96, we'll go ahead and right-click and simply mark it so we can find it later if we forget 96. Let's go back to our preferences again. And in preferences, if we take out 6783 and click on apply, and I'll close this now. So you'll notice now for packet 96, which we're still taking a look at here, it just says it's data. It doesn't know exactly what it's all about. And why is that? Is because it doesn't know which dissector, the HTTP dissector, that should be allocated to interpret what that data is. But Keith, you said there was 3 options when we're using non-standard ports, and they were, number 1, hope that the heuristic dissector automatically figures it out based on the stream of data, what type of traffic it is, and can correctly associate the right dissector with it. Number 2, modify the ports, which we just did. And the third option is to force a specific dissector on that traffic. So for example, for packet 96 here, if we right-click and we want this to be decoded as HTTP, all we need to do is go right here and say, please decode as, and then click on the protocol that we want it to go ahead and use. So in this case, I'm going to say for transport, I'm going to scroll down, I'm going to say traffic between 6783 and 49222, which 49222 is the random high-numbered source port that the Windows 8 machine chose to use when it initiated that session. And I'm going to scroll down and say, I want to go ahead and use HTTP for that. Select it, click apply, and you'll notice that now in 96, this packet right here, it now knows its hypertext transfer protocol, and because we have the appropriate dissector working against it to see the data, it now is showing us meaningful information about this application layer of HTTP. So Keith, it says unauthorized right here. What in the world is that about? I mean, we logged in successfully. How come it says unauthorized? And the reality is we were only authorized after I put in the username and password correctly, and then we could log in. This message came back to us when we initially connected prior to us putting in the credentials. In this video, we've identified the job of a dissector. It's a very specialized interpreter for a specific portion of a protocol stack. We also explained how Wireshark knows which dissector to use based on cheating. It simply looks at the protocol indicator or the type in the layer below it. That helps it interpret what those dissectors should be. For non-standard ports, we can hope for the best, and sometimes it does get it right. We can modify the ports based on a specific protocol inside of Wireshark so it recognizes those ports, or if we need to, we can force the dissector as I just did. So here's what I'd like you to do. I'd like you to download this capture file that we saved just a few moments ago, and when you open that up in Wireshark, what I'd like you to do is find that non-standard HTTP port number that we demonstrated in class, and I'd like you to manually assign the correct HTTP dissector to it. Now, one of the best ways of doing that would be this. Download the file, have it ready, walk through this video again step by step, and just follow exactly what I did. In addition, if you want to practice with your display filters or adding columns or sorting it any way you want to, additional practice is always helpful as you increase your comfort level in working with this amazing tool called Wireshark. I am so glad you joined me for this video. I've had a really good time. I hope this has been informative for you, and I'd like to thank you for viewing.